Alright, Math 111, we're going to talk about Section 9.5 logarithms today. Well, look at this statement here. The log of A base B equals C. What does this statement mean? Well, this means that B to the C power equals A. There's a way I can put this in words. This expression is in logarithmic form. And this is the same expression really, but in a different form. This is exponential form. And if we consider the details here, this is telling me C is the exponent we put on B to get A. So if I ask you, for example, what's the log of A base B, I could say in words this is the whole thing, right? The whole logarithmic expression. This is the exponent we put on B to get A. Alright, that may seem a little abstract. Let's try a concrete example here. What's the log of 8 base 2? I claim, by definition, this is the exponent we put on 2 to get 8. Well, what is that? Well, I'll say, let's rewrite this in a different way. Let's say I want you to find the log of 8 base 2. So I'm really asking you, what power do I put on 2 to get 8? In other words, I can rewrite this expression in an exponential way, exponential form. I'll say 2 to what power equals 8? And of course, you're going to tell me 3. Question mark equals 3. So I can say that the log of 8 base 2 equals 3 because 3 is the exponent I put on 2 to get 8. Let's try another example. Let's say the log of 64 base 4. Let's say I don't know what it is. This expression is the what we put on what to get what, and I'll ask you to fill in the blanks. Right? The log of 64 base 4 is the exponent we put on 4 to get 64. That's by definition. Right? So if I ask you what exponent do I put on 4 to get 64, I'm asking you, and then what is question mark here? And of course, question mark is going to be 3. So I claim the log of 64 base 4 is 3 because 3 is the exponent we put on 4 to get 64. Now again, this takes some getting used to. You're going to have to be able to go from logarithmic form to exponential form pretty fluently. Okay? Every logarithm has what they call a base. By agreement, we claim that the base cannot be has to be hang on. Logarithm bases are greater than 0 and cannot be equal to 1. A is what I call the log argument, and C is the logarithm itself. The log of A base B equals C. Alright, and again, this expression here, log of A base B equals C, this is in logarithmic form. I should be able to go back and forth to exponential form very easily, right, with little practice. Right? I like to think of, well, if the base of the logarithm is here, then that would be the base of the exponential form over here. Okay? Let's try some harder examples. You can refresh screen. Yeah, let's see. What is the log of 1/36 base 6? So I'm going to ask you to compute that for me. Right? Well, I'll tell you what. Instead of question mark, let's call it x. And I'll ask you to solve this logarithmic equation. Well, if the log of 1/36 base 6 is x, that means x is the exponent we put on 6 to get 1/36. In other words, this is in log form, and this statement is in exponential form. Well, let me ask you, what exponent do I put on 6 to get 1/36? Well, of course, we'll recognize 1/36 as 6 to the minus 2 power. So I claim x equals minus 2. Minus 2 is the exponent I put on 6 to get 1/36. So I'll claim the log of 1/36 base 6 is minus 2. And let's try some other logarithmic type equations of this type. Alright, let's say I ask you to solve this equation. Well, I'm going to give you basically 3 different types here. We've got 3 slots to fill in an equation of this type. So if I have 2 numbers in 2 of the slots and a variable in the third, we should be able to solve for the unknown here. The log of 25 base x equals 2. This means that 2 is the exponent we put on x to get 25. If I rewrite this logarithm form equation into exponential form, hence I get x squared equals 25. 2 is the exponent we put on x to get 25. Alright, so this is log form. This original equation is in log form. This equation is converted into exponential form. Still has the same information. And if x squared equals 25, that of course means x is 5. I suppose you could claim x equals minus 5, but remember we are assuming that bases in logarithms are always positive and cannot be 1. And so the answer to the solution for this equation is x equals 5. That last equation was example was with the variable in the base slot. Let's try something else here. Let's say I ask you to solve this equation. The log of x base 3 equals minus 3. Alright, so we're asking the logarithm of what number? Base 3 is minus 3. And then, again, this is in log form. To convert it to exponential form, I would say minus 3 is the exponent we put on 3 to get x. Alright, and once we see it in exponential form, it's very easy to solve. x essentially almost solved for. X is, well, what's 3 to the minus 3 power? That's 1 over 27. So the solution to this equation is 1/27. Try another one. Solve this equation. The log of 64 base 8 equals x. Alright. Again, this is in log form. Alright, this statement tells me x is the exponent we put on the base 8 to get 64. Hence, in exponential form, I can rewrite this equation. 8 to the x power equals 64. And I'm sure by inspection you recognize that 64 is 8 squared. So x equals positive 2 would be the solution to that equation. Solve. The log base 3 of 1/3 equals x. Again, here the variable is on the other side of that log operation. So what we're saying here, again, this is a logarithmic form. So I'm saying here x is the exponent we put on 3 to get 1/3. X is the exponent we put on 3 to get 1/3. This is in exponential form. And if 3 to the x is 1/3, well, I'm hoping you'll recognize that x has to be minus 1, right? Because 3 to the minus 1 is 1 over 3, or 1/3. So x equals negative 1 in this equation. Another one. Solve. The log of 81 base x equals 2. Well, here's another one where the base is a variable. Again, this original equation is in log form. Probably the easiest way to solve it is to convert to exponential form. Namely, 2 is the exponent we put on x to get 81. 2 is the exponent we put on the base x to get 81. And if x squared equals 81, that means x equals 9 or negative 9. But again, we're assuming now that bases, x is a base here, bases cannot be negative in logarithmic type equations. Alright, got a couple more. We'll call it a day. What is the, if I ask you to solve this logarithmic equation? The log of x base 5 equals minus 2. Alright, here the variable is inside the logarithm argument. Well, the logarithm of what number base 5 is minus 2? That's what we are asked to solve. Again, this original equation is in log form, so I'll convert it to exponential form. Make it a little easier to solve. Minus 2 is the exponent we put on 5 to get x. Minus 2 is the exponent we put on 5 to get x. Alright, so what is 5 to the minus 2 power? Well, that's 1 over 5 squared, and that's 1/25. So my solution for x is 1 over 25. Let's try a little harder one. This one is from the homework assignment. Basically, this one's in the upper reaches of the homework assignment. So if you can handle this one, you'll probably be able to do all of them. Again, here the logarithm expression is a base. Or the variable is a base. Alright, so I'll start out in logarithmic form and converting to exponential form. if the log of 0.001 base x equals minus 3, that means minus 3 is the exponent we put on x to get 0.001. Minus 3 is the exponent we put on x to get 0.001. Alright, we might have to think about this one a little bit. X to the minus 3 power equals 0.001. Well, let's think for a minute. 0.001 is 1 over 1,000, is it not? And what is x to the minus 3? That's really 1 over x cubed. Alright, so if 1 over x cubed equals 1 over 1,000, well, that is equivalent to the denominators being the same, since the numerators are the same. Alright, so if x cubed equals 1,000, well, then it's an easy conclusion that x equals 10. Alright, so the log of 0.001 base x equals minus 3, the solution to that equation is x equals 10. Alright, so this concludes section 9.5, Introduction to Logarithms, or what the book calls Logarithmic Functions, and that is all.